Hello everyone. So now, coming to this question, yt is equals to 2 of x to t, you need to find out you need to comment on the linearity, variancy and the causality of the signal. So like I've already done and then calculated, now I'm just going to explain you that at t is equals to t naught, firstly we are checking whether the system is causal or not. So for the first process that I have explained, it is of the causality. So to x to t naught, at t is equals to t naught, we get to x to t naught. So how to check the causality? Cause for checking the causality, firstly I'll explain you that one negative value plus one positive value is taken into account for checking the causality. Like one positive value we are taking as y is equals to, at t is equals to plus 1, and negative value at t is equals to minus 1. So at t is equals to 1, we get 2x, 2 into t naught is 1, so 2x into 2. So we get value at t is equals to 0, t is equals to 1, we are getting the value to x2. So at t is equals to minus 1, we are getting to x minus 2. So we can see that the value, for the value to be known at 1, we need the value at input 2. So what we can infer from this equation number 1, like present for the present input, we need to find out the future value. So since you need to note down in every equation of signal, if we comment on the causality, if the signal is, whenever the input value is applied at smaller interval and we are getting the value at higher interval, that is, so future value, we can say that the input depends on the future value, that is at t is equals to 1, it depends on t is equals to 2 value. So we can say that the system is non-causal always. The system is non-causal always when any of the input depend on the future values. So likewise, we can say that at t is equals to minus 1 means is minus 1 is past value is depending on the past input, that is t is equals to minus 2. As t is equal to minus 2 comes before, then t is equals to minus 1. So we know that, you all know that minus 2 is less than minus 1 in the real axis. So second of the so at t is equals to minus 1, we are getting the causal value, but because the first part is already been non-causal, so we can say that this whole system is not causal. Okay, so same thing. And the next question, so yt is equals to 2x t naught, t by 2, again commenting on the linearity, we should note the point that whenever the constant multiplication is done, or if any multiplication is done which is not a function of time, basically, then the system cannot make this multiplication cannot make the system non-linear. Okay, so at t is equals to t naught, yt naught is equals to 2x t naught by 2, replacing the value t at t is equals to t naught. For negative value, we take minus 1 for checking the causality, again minus 1 at t is equals to minus 1 to x of minus 1 by 2. For taking the positive value, we take y at t is equals to plus 1, taking the positive value as we have done in the previous question, 2x 1 by 2 plus 1 by 2 is this. So for t is equals to minus 1, we can say that it is depending on the future value. Why? Because minus 0.5 comes after the minus 1 value in the real axis. How? I'll show you. This one, if it is minus 1, then here comes minus 0.5. You can see. So minus 1 comes before minus 0.5. So we can say that an input for the previous input, we are getting the future value, that is at t is equals to minus 0.5. So we can infer from the, as I've already told you that and it's a fact that if half part of the equation comes out to be non-causal, then then the whole system comes out to be non-causal only. So 2x 1 by 2. For t is equals to minus 1, it is depending on the future value. So for t is equals to plus 1, we can see 2x plus 1 by 2. So we can see that t is equals to plus 1 comes after t is equals to 0.5 plus 0.5 when we talk about the positive real axis. So this part of the equation is causal obviously, but because the first part is already been non-causal, so this part will be non-causal. So the whole system will come out to be non-causal. So checking on the, so this is the whole process of time variancy. So now commenting on the time variancy, why putting t is equals to minus t naught, y of t minus t naught in this particular equation to x t minus t naught. So z of t, well, let's say z of t is equal to x t minus t naught. So z of t minus t naught is equals to 2x t naught by 2 minus 2. This one. Using this to x t naught by 2. So is equals to y dash t. So time variant, because and zt the, so a detailed expression is described in this part. So zt is equal to 2z of t naught by 2, zt is equal to t by, as we have assumed that z is equal to t minus t naught. So here zt, in place of t we are using the value t by 2 because of the equation. You can see, I don't need to repeat it again. So t tends to t naught minus t by 2 minus t naught, so z of t minus 2 minus t naught, 2z of t minus t by 2 minus t naught. So this value is different, so it is time variant. Okay. Now we are taking the next equation, y of t is equal to 2 of x of minus t. This is another set of signal equation. We need to find comment on the cause on the linearity, time variancy, or next thing, the causality and all. For causality, we know we are taking value at positive interval and negative interval. So for negative interval at t is equals to minus 1, using this 2x of minus 1 into minus 1 plus 1. So for previous value we are getting the future value, as t is equals to minus 1 comes before t is equal to plus 1. So future value depends on, so it is non-causal. Okay, yeah, and simply we can say that the system is non-causal. We do not need to worry about it. So for commenting on the linearity, if the scaling is done, scaling is there, linear or non-linear system will definitely be non-causal. Okay. It was linear always, because since it is not multiplied with any of the time functions, since 2 is not a time function, 2 is a constant, so non-linearity will not take place, it will always be linear. So for this equation, if we come talk about for linearity, it is linear since sine is not a function of xt. Since sine is not a function of xt. If the sine would have been a function of xt, then the system would automatically become non-linear. We don't need to think any more in that. So for time variancy, we don't need to find out whether it is multiplied with the constant or not. If here sine of xt would be written, then system would become non-linear automatically. So for time variancy check, zt is equals to xt minus t naught. Okay, placing t is equal to t naught. Whenever we put apply input xt, we get a system output as sine x of sine t. This one. So likewise, zt, when we put zt as an input, we'll get a z sine t as the output. as the previous equation. So z of t minus t naught will give z of t sine t minus t naught y dash of t. So system is time invariant. Why? Directly the variancy can be found out, as if this was the function of xt, then we can automatically say that the system is non-linear. Sorry, time invariant. Time variant is time variant. For causality, we have already checked, and for linear is also done. Everything is done. Okay.